Hi everyone, my name is Kang. I'm from Artwork Department from Group 7 with under supervision of Prof. Madhya Dr. Mushari bin Mustafa. My company name is called BTH Construction. Now, I'm going to present my major presentation for Integrate Design Project 1. These are my teammates from Artwork Department. Li Yihao as Head of Department, followed by Dawisha, Qin Xuanying, and also me myself. The project we received is located at Urutiram, Johor Bahru. The total area of this project is 430,771 meters square. The aim of this project is to develop an industrial and commercial area with a variety of factories for economical purpose and facility that can be used by workers. As a member of Artwork Department, we need to take a site securing and propose a new design level for it. We did our design step by step, so the sequence steps of our design are shown here. Start from introduction, scope of work, site planning, proposed level, cut and fill, long section and cross section, slope stability analysis, and finally the conclusion. First is some introduction about what Artwork actually is doing. Earthwork is the process that involving excavate, transported, and compacted the surface of Earth at another location. Earthwork mainly carried out at earlier stages of construction. The planning of the earthwork can give the contractor positive result to their profit and the quality of project, whereby while planning the earthwork, they should analyze the work to be carried out and determine the types and numbers of plants that would be most suitable to the sequence of operation. First and foremost, the land should be clear for easier access of heavy machinery to aid in the process of carrying out earthwork. This execution is vital in reconfiguring the topography of the site to achieve the desired level of design. When earthwork activities are not conducted properly, it will affect the surrounding environment. First is soil erosion and sedimentation. These processes occur when earthwork materials are worn and start to get carried away by natural forces such as wind and water. When there is no proper planning, there will be unscheduled of use of machinery, thereby increasing the noise pollution rate at the site area. It will impact the acoustics of the area due to the cut and fill process that changed the original landscape. We have to carry out site inventory and analysis in order to take note of the reduced level of existing topography, road levels, and utilities that were already on site. We have to consider the cut and fill volume to achieve the desired reduced level and minimize the cost. The difference between cut and fill volume should be less than 15%. The scope of work. Here are the scope of work that done by us. At first, site inventory and site analysis on site need to be carried out first. After we have all the topography data, we will propose a new design level on site. To check the adequacy of the proposed level, the calculation volume of cut and fill needed is taken. After that, we also have the long section and cross section view between the two levels. Finally, we check the slope stability by short simplified method. Here comes to the site planning first. The first step is site inventory. Site inventory basically consists of a list of existing elements and observation on the property. It is also the first and vital step of a site planning process to provide a clear description of the proposed development level. Proper site inventory is important as a way to conduct a survey on the condition of the proposed site, including the soil and topography of the area, built feature, and activities already. Based on this detail, we can locate existing contour, steam or waterway location, drainage, and also indicate the proposed development component. This is the area view of Taman Datuk Shalem, Uru Tilam, Johor Bahru. Throughout the site inventory, we found that they have school, apartment, factory, water tank, culvert, short lot, residences, water treatment plant, plantation, and toll plaza around the project area. Next is site analysis. Site analysis is a preliminary phase of architecture and urban design processes dedicated to the study of climatic, geographical, historical, legal, and infrastructure context of a specific site. Site analysis is carried out before proposing any suitable level to analyze the existing features. This is to ensure the proposed level could synchronize with the surrounding features to avoid steep slope and also a big difference in the elevation for the proposed plan. From the analysis for the proposed area, the highest level in boundary is 88.99 meter. The lowest level in boundary is 31.17 meters. And the difference between the lowest elevation and the highest elevation is 57.82 meters. The plantation will cut down from the project. The water tank will also be placed at the highest area, whereas the retention pond will be built at the lowest area of the project. After the site planning is done, then we will have our proposed level now. A proposed level is set based on the existing topography of the site area after the site inventory, because there was a large difference between the highest point and also the lowest point for the initial existing level. The steep slope and mountain will make the construction difficult to proceed. Steep slopes are prevented from the proposed level, so the proposed level can minimize the difference of cut and fill volume to reduce the cost of construction. Next is cut and fill needed for the difference of level. After the upward level is proposed, the higher surface at the site need to cut, and the surface will have lower than the proposed level need to be filled up with the soil. So the difference between cut volume and fill volume need to be minimized because we need to reduce the transportation cost of transfer the soil from the site. So in this project, spot height method is used to calculate the cut volume and also fill volume needed to achieve the proposed level. So to conduct spot height method, the site layout was divided into many small grids. The existing level and proposed level of each corner of each grid are inserted in Microsoft Excel. Then the difference between the average existing level and also average proposed level of each grid is determined to find out the volume of difference. So the dimension for each grid is 30 meter times 30 meters. So the area of one grid is 900 meters square. And the percentage difference of the total cut volume and total fill volume, we need to make sure that it's below 50% to save the cost. We use grid 1A as our sample calculation. So let us have a look now. First, we need to find out the average existing level of grid from the contour line. After that, we find out the average proposed level at the grid also. We find out the difference between average proposed level and also existing level. So if there is a positive difference, means that the area is higher than proposed level. So a cut is required at the grid area, and if there is a negative difference, means that the area need to have a fill. because it's lower than the proposed level. So the calculation for the others grid are shown at the table here. There are total 546 grids at this project site. So start from grid 1A, 1B, 1C until number 546 grid. So if the grid is needed a cut, we will write, it will show here in the cut volume. And if we need a fill, then it will show in here. From the summary of cut and fill calculation, we will find the two volume, final volume for the cut volume and also fill volume. However, because when the soil is come out from the compact condition, we need to consider 10% of bucking factor for the cut volume, as it will increase the volume when it contact with the air. So the result for the total cut volume was increased to 105594.6 meter cube, and the total fill volume is still the same, which is 1057762.4 meter cube. So the percentage difference between the cut volume and fill volume is 0.17, which is lower than 15%. Therefore, this proposed level design is accepted. Next, after the proposed level, we also have the long section and cross section view for the proposed level and existing level, because we need to find out the difference between these two levels. There are total 4 sections we did. The first section of this line AA is a long section, whereas the section of BB, CC, and DD is shorter, so it is a cross-section view. The long and short cross-section show the profile of existing and proposed level at each section. The cut and fill area for each section are then determined by comparing their levels, where the green color represents the fill area, while red color represents the cut area of that section. These cross-sections are useful to demonstrate how the plan of earthwork are going to be implemented on the existing ground level. So based on the cross-section plotted, we can say that the proposed level was set strategically since most of the cross-section has approximately equal area of cut and fill. We can save the overall project cost by minimizing the difference between total cut and fill volume of the earthwork. After the proposed level is set, we need to have a slope stability check on it. Slope ability withstand ground movement. An unstable slope may lead to fatalities to building or even human life. Hence, slope stability is an important factor in construction projects to ensure that there will be no occurrence of slope failure at the construction site or when the construction is finished. Slope failure may occur due to construction activities. The construction site is exposed to the possibility of natural disasters such as flash flood, mudslide, and also landslide. In order to protect the development of building and infrastructure in the duration of the construction, it is important to take into account the stability of natural and man-made slope. So slope analysis and design are required to carry out the development area to determine the best and safest slope that has a minimal chance of failure. So we have decided to use Bishop simplified method in this project. The simplified Bishop method is based on the method of slide to decrease the soil mass in order to derive the factor of safety Fs, which indicates the slope stability of a slope. Therefore, first, the moment of equilibrium from the whole surface of failure with respect to the center of rotation. Second, the horizontal force equivalent for the overall surface of failure. And third, the vertical force equivalent for each slide. The factor of safety we need to be more than 1, if not, the slope failure may occur. The radius of the circular failure of the slope is assumed to be 10 meters, and the slope has been divided into 10 slices with a radius of circular failure of 10 meters. At the end, the factor of safety we get is 2.26, which is more than 1. Hence, the slope is stable. Lastly is some conclusion about the earthwork. In conclusion, earthwork is the work that involves moving of massive amount of soil from the ground. To conduct the design of earthwork, site inventory and site analysis are needed to identify the conditions surrounding the site. The difference of existing site level and proposed level need to be minimized to reduce the cost of cut and fill. The cut and fill volume difference we got is 35 because it's only 0.17% and we save a lot of transportation costs. Based on the slope elasticity, we have obtained the factor of safety of 2.26, which is greater than 1.0. This indicates that the slope is straight and stable when calculated using the assumed circular failure radius of 10 meters. To conclude, construction activity can now be performed. That is all from my major presentation. Thank you very much for watching finish it and hope you have a nice day.